Let's look at another limit that comes up fairly often. The limit of 1 minus cosine of x over x as x tends towards 0. So let's divide it in half. We'll use that right-hand side as our scratch pad. The first thing we're going to do is multiply both the numerator and the denominator by 1 plus cosine of x. So the numerator and the denominator. That will give us the limit as x approaches 0 of 1 minus cosine squared of x over, that's the difference of squares, x times 1 plus cosine of x. Now that 1 minus cosine squared of x probably looks familiar. One of the great trig identities, sine squared x plus cosine squared x equals 1. And we can subtract cosine squared from both sides to get sine squared x equals 1 minus cosine squared x. So now we can take that sine squared x and we can substitute it in for our numerator. So rewriting that, that is the limit as x approaches 0 of sine squared x over that denominator, x times 1 plus cosine of x. Now we know that because it's a limit, if we take the product, if we have a product here, we can divide this fraction up and it's the same as the limit of the two separate products. So this is the same as the limit of sine x over x as x approaches 0. And we had a whole video on that one, multiplied by the limit as x approaches 0 of sine x over 1 plus cosine x. Okay, so we can see that we've got that sine x over x. We know that sine x over x, as x approaches 0, tends towards 1, so that limit is 1. We proved that by the squeeze theorem. So we can say that that's the same as 1 times the limit as x approaches 0 of sine x over 1 plus cosine of x. Now as x tends towards 0, we know that sine x goes to 0 and 1 plus cosine of x goes towards 2. So 1 times 0 over 2, which is 0, equals 0. So the limit as x approaches 0 of 1 minus cosine of x over x equals 0.